I'm hopeful that we can, within less than a year of AI5 starting production, we can actually transition in the same fab to AI6 and double all of the performance metrics.
Tesla just finished work on a mysterious new AI chip, and the announcement shocked people across the tech world. Elon Musk hinted that this design could replace everything Tesla has been using before. Something big is happening inside Tesla's robot program, and this chip is at the center of it.
Just get everyone focused on the AI5 chip, which is essential. Continue to use Nvidia for training, but we need the AI5 inference chip, which is it's a very powerful chip, but it's also a very low power. But it doesn't use a lot of power. So its performance per watt is extremely good. We think, probably going to be at least 2 to 3 times better than Nvidia in performance per watt.
Musk described the chip as epic and stated that the follow-up AI6 chip has a shot at being the best by AI chip by far. The AI5 chip targets models below approximately 250 billion parameters, with Tesla claiming it will deliver the lowest cost silicon and best performance per watt for this category of AI inference. Tesla announced during its third quarter 2025 earnings call that the AI5 chip will provide up to 40 times the performance of its predecessor, the AI4 chip, in certain metrics. The new architecture includes 8 times more raw compute power, 9 times more memory, and 5 times higher memory bandwidth compared to AI4. The chip is expected to deliver between 2,000 and 2,500 T OPS trillion operations per second. The AI5 design eliminates traditional GPU components and image signal processors that were present in AI4. This streamlined approach reduces the chip to half the size of full reticle designs from competitors like Nvidia and AMD. Tesla's custom optimization focuses specifically on the company's autonomous driving and robotics applications, removing hardware features that don't serve these purposes. Manufacturing of the AI5 chip will be split between 2 foundries. TSMC will produce the chip at its facility in Arizona, while Samsung Electronics will manufacture it at its plant in Taylor, Texas. Musk noted that Samsung's Texas facility has slightly more advanced equipment than TSMC's Arizona location. Both facilities will manufacture slightly different physical versions of the same chip design, though Tesla's AI software will work identically on both versions. Production timeline for AI5 has been clarified through multiple announcements. Musk stated in November 2025 that AI5 will not be available in sufficient volume to switch over Tesla production lines until mid-2027. Tesla plans to produce samples and a small number of predicted units in 2026, with high-volume manufacturing beginning in 2027. The company will need several 100,000 completed AI5 boards before transitioning vehicle production lines. Tesla's explicit goal is to create an oversupply of AI5 chips. Any chips not installed in vehicles or Optimus robots will be redirected to Tesla's data centers. The company already uses AI4 chips in combination with Nvidia hardware for data center operations. Tesla's data centers currently operate with computing power equivalent to 81,000 Nvidia H100 chips. The AI6 chip development runs parallel to AI5 production. In July 2025, Tesla signed a $16.5 billion contract with Samsung Electronics for AI6 chip manufacturing. The deal spans from July 26, 2025 through December 31, 2033. Samsung's Taylor, Texas fabrication facility will handle AI6 production, with the facility located approximately 30 minutes from Tesla's operations. The AI6 chip is designed as a unified architecture that scales across multiple applications. It will power full self-driving systems in Tesla vehicles, serve as the processing core for Optimus humanoid robots, and support AI training workloads in data centers. This single-chip approach represents Tesla's strategy to eliminate separate hardware for different use cases. Both Samsung and TSMC will manufacture AI6 chips using the same dual foundry strategy employed for AI5. Musk confirmed that AI6 will use the same fabs but achieve roughly 2x performance compared to AI5. The projected performance improvement positions AI6 as approximately 80 times faster than AI4 in specific workloads, assuming the stated 2x gain over AI5's 40x improvement. Mass production of AI6 is expected to begin around 2028. Samsung and Tesla have set production yield targets between 60% and 70%, with Samsung aligning its manufacturing processes to meet these specifications. Equipment installation at the Taylor facility began in 2025, followed by test production phases. The financial scale of Tesla's chip investment extends beyond the announced figures. Musk suggested on X that the Samsung deal could likely be even larger than the announced $16.5 billion. Samsung agreed to allow Tesla specialists to assist in maximizing manufacturing efficiency at the Exler facility, with Musk stating he would personally walk the production line to accelerate progress. Tesla's chip development extends beyond AI5 and AI6. Musk announced in November 2025 that AI6 and AI7 will follow in fast succession and that AI8 will be out of this world. The company maintains an aggressive roadmap for successive Revide chip generations, each targeting specific performance and efficiency improvements. The business implications affect multiple sectors. Tesla's automotive division sold 1.79 million vehicles in 2024, creating substantial demand for custom silicon as the company scales full self-driving deployment. The Optimus robot program adds another application requiring dedicated processing power. Data center requirements compound these volumes as Tesla expands its AI training infrastructure. Samsung's foundry business has struggled with profitability, with losses exceeding $3.6 billion in the first half of 2025. The company holds 8% of the global foundry market, compared to TSMC's 67% share. The Tesla contract represents approximately 7.6% of Samsung's 2024 annual sales revenue, making it one of the largest single-client foundry orders Samsung has secured. Something huge just happened in the robot world, and no one saw it coming. Out of nowhere, a Chinese tech giant made a move that could change the entire future of humanoid robots. Factories went into overdrive, corders exploded, and suddenly, even Elon Musk's Tesla project was under pressure. But what exactly did they build, and why is everyone so nervous about it? UB Tech, based in Shenzhen, reported a surge of industrial orders for its Walker S2 robot through 2025. The Walker S2 is designed with an autonomous battery swapping system that enables continuous operation without human assistance. The robot's development represents a move from experimental prototypes to large-scale industrial deployment. The model was first shown publicly in July 2025, followed by a 250 million yuan contract for use in major industrial facilities. Another 159 million yuan deal was announced for a data collection center in Sichuan province, bringing the year's confirmed total above 800 million yuan. UB Tech scheduled delivery of the first mass-produced units for November 2025. The robots are being introduced to real manufacturing and logistics environments, indicating that China's robotics industry is entering an active commercial phase. XPeng, known primarily for electric vehicles, unveiled its humanoid robot named Iron. The robot operates using solid-state batteries and features a bionic muscle system combined with advanced artificial intelligence control. XPeng stated that Iron would be produced in both male and female configurations and aimed at office, retail, and service environments. Mass production is expected to begin before the end of 2026. Meanwhile, Unitree Robotics advanced its own humanoid model, the G1. This robot is designed with force-position hybrid control technology, giving it precise manipulation abilities similar to a human hand. The G1 targets educational and industrial markets and is also slated for commercial-scale production. Together, Iron and G1 highlight how China's robotics companies are developing in parallel across both industrial and service sectors. In the United States, Tesla's humanoid robot Optimus remains under development. Tesla describes Optimus as a general-purpose bipedal robot capable of performing repetitive or hazardous tasks. Elon Musk has stated that up to 80% of Tesla's future valuation could eventually come from the Optimus program. Despite these ambitions, the company's progress has been slower compared with China's industrial rollouts. As of late 2025, Tesla has continued testing limited prototypes and is refining its machine learning strategy. The company has shifted from motion capture training to a vision-based training approach similar to the one used in its self-driving vehicles. Production challenges have also emerged due to restrictions on exports of rare earth magnets from China, materials essential for Optimus's electric motors. Tesla plans to produce thousands of Optimus units by the end of 2025, but no large-scale commercial deployment has yet been confirmed. The robots remain in controlled testing inside Tesla facilities. By contrast, UB Tech and other Chinese firms are already delivering robots for operational use in logistics, manufacturing, and data facilities. This difference shows how China's robotics sector is rapidly moving from research to revenue. China's push aligns with its broader industrial policy, promoting automation and artificial intelligence to upgrade factory productivity and reduce labor dependence. Government support has been strong, with robotics classified as a strategic priority. The Walker S2, Xpeng Iron, and Unitree G1 collectively represent the country's strategy to gain leadership in humanoid robotics across multiple application fields. These developments could significantly reshape manufacturing dynamics, cost structures, and global labor allocation. Despite fast progress, several challenges remain across the industry. For all humanoid robots, operational stability, maintenance costs, and safety in human environments continue to require technical refinement. UB Tech's growth in sales has not yet produced profitability. The company recorded a first-half 2025 net loss of about 440 million yuan, even as revenue rose over 27.5% to 621 million yuan. High production and research costs remain barriers to mass affordability. Experts also emphasize that humanoid robots still struggle to perform complex physical tasks in unpredictable environments for long durations. In Tesla's case, the training requirements for Optimus are considered significantly higher than those for the company's vehicle software. Optimus's perception and coordination must handle multi-joint motion in three-dimensional spaces rather than a fixed vehicle platform. This makes the scaling of training data and computing power a substantial hurdle. Musk has indicated that the company's artificial intelligence team is expanding resources to accelerate learning models for Optimus, but production readiness remains uncertain. For China's companies, the next stage involves refining reliability and cost per unit while expanding integration with existing automation systems. UB Tech's Walker S2 has already been assigned to large industrial sites for assembly and inspection tasks. Xpeng is planning controlled deployments of its iron humanoid robots in showrooms and corporate spaces to demonstrate performance in public environments. Unitree's G1 continues to attract interest for training and research use, contributing to broader robotics adoption within China's education and technology ecosystem. Across the global market, these advancements mark the transition of humanoid robotics from prototypes and demonstrations to real industrial roles. As of late 2025, China holds measurable advantages in volume orders and actual deployments. The United States, through Tesla's Optimus and other initiatives, remains a major player, but faces slower commercialization timelines. The competitive momentum underscores a changing landscape in automation. Chinese manufacturers are entering a production phase, delivering hundreds of working robots, while American counterparts remain in testing. Elon Musk's projection that Optimus could be central to Tesla's long-term value will depend on the company's ability to achieve similar industrial penetration. The rapid development and commercialization pace in China illustrate a significant lead in humanoid robot deployment. China's government continues to emphasize robotics integration as part of its manufacturing upgrade agenda. The presence of UB Tech's Walker S2 on factory floors, combined with the emergence of Xpeng's Iron and Unitree's G1, signals that the next stage of humanoid automation has already begun. Meanwhile, Tesla's Optimus project, though technologically ambitious, remains in a critical phase where testing and scaling must transition into tangible production output to keep pace with the accelerating competition.